Today, I will show you how easy it is to build a custom Firebase server that can talk to the vanilla clients. So why should we build a Firebase Realtime Database? Well, from conversations I've had in Europe, some people are concerned about data processing. So if we had our own open source Firebase Realtime Database, we could put it in whatever data sovereignty we want. We can remove that Google dependency, as some people are concerned that Google sometimes cancels products. The database itself has a lot of good features. It's been very popular in the market, has a lot of deployments in the iOS and Android mobile apps marketplace, as well as significant traction in the web space as well. It's got many different language clients, even C++. And these clients have been battle tested, some of them for 10 years now. It's always preserved backwards compatibility. So it's a good piece of technology. And Google already open sourced the clients. So it's just there, ready to be picked up. The only bit we're missing is the server, and that's the easiest bit to develop. So what is the Firebase Realtime Database? Well, firstly, it's not Firestore. Firestore is the latest database developed by Firebase, and Firestore is the Google technology. It's gRPC based, and actually I think this choice of transport of gRPC makes it less desirable as a systems component, whereas the Firebase Realtime Database is WebSocket based. It has faster connections times and lower latency. So yes, it's less expressive, but it's higher performance. And I think the Firebase Realtime Database is something that can be used in a variety of different systems. It's very badly named. Calling it a database makes you think it's good at querying. It's not very good at querying. What it is just a key value store. So maybe we should have called it the real-time key value store. It's causally consistent. It does optimistic updates, which means it allows you to read your own writes before it's got synced to a centralized server. And it also supports offline persistence. So the Firebase Realtime Database does not need to be online to work. The Firebase SDK in general has problems with authentication offline, but that's not a problem with the Firebase Realtime Database. That is offline first. So all in all, I chose quite consciously that the Firebase Realtime Database is the more desirable technology to have an open source version of. So if we create an open source Firebase server that you can host anywhere, we can unlock all that technology for new use cases. So let's have a look at how the real-time database is architected. A config configures a client, which then talks back and forth to a server using a wire protocol. In part 1 of this talk, I will show you how to use the config to send a client to a third-party server implementation. In part 2, I will show you how to reverse engineer the wire protocol. We will know when we have succeeded when we can use a vanilla client against our own third-party server implementation. There are many existing resources available that help us understand the Firebase wire protocol. One valuable resource is a previous effort by GitHub user Urish to create a third-party Firebase server for testing. As you can see, the code is fairly simple to understand. In this sample, if an incoming message has an L, the server handles a listen. A listen is something we might call a subscribe or a query in other contexts. In addition, of course, we also have the Firebase client source, which is licensed under MIT. The JavaScript client source shows 11 unique actions the client wants the server to respond to. The client will also emit detailed protocol debugging information at runtime if you ask it to by calling enable logging. And you can redirect the logging output to alternative printers, which is a trick used in the wire protocol notebook to display on screen the SDK logging output. Another useful source is the browser developer tools, which you can use to inspect running WebSocket and HTTP conversations on a live client. I've tried to wrap up all this information into a single interactive literate programmable notebook experience called the Firebase Realtime Database Wire Protocol Explorer, which is linked to this talk and lets you perform all these experiments at home. So now let's take a look at how a client is booted. Firebase's documentation provides us with a snippet of configuration, including a database URL. So our first investigation is what happens when we mess with that. First, when the client boots, it logs that it connects to a server on a related domain. And when we look at the network log, we see a network request with the database name passed as an NS parameter to a subdomain. When the client is in long polling mode, the server responds with a JSON-P script, which sets the foundation for 2 data channels. When we look at the client source code, we see an alternative passing of the database URL config, which uses this subdomain and NS parameter form. So we can instantiate a database client using this alternative form of a database URL. We can use this form to target a third-party server. Let us define a web server, and we set a breakpoint on the first line of its request handler. This web server has a public URL. Next, we instantiate a Firebase client with our third-party domain, and we use the NS parameter to encode additional routing information. We pop open Chrome Developer Tools. We turn on the web server's live code tunneling. Now we boot our alternative client and we catch a request. Now, if we step through, when our server returns a JSON-P response and we let the server continue, and it's made a healthy connection. So this establishes we can connect to third-party servers using an unmodified client. When in long polling mode, if we regurgitate a JSON-P document, some data channels are set up, and it's over those an ordered wire protocol communicates bidirectionally with the server. So let's see what happens when a listen is sent. First, the server receives a request containing a base64 encoded JSON parameter. When we decode and pass that parameter, we see a Q for query in the A for action field, and we see the URL next to a P for path field. If the server responds with data before it's responded to the command, the client interprets the initial data as the initial result set. Here we send the data payload containing hi. Next we respond to the initial listen command with OK. And ta-da, when we unpause everything, the SDK logs the command response and the cell itself evaluates to hi. So that demonstrates we have cracked the Firebase Wire protocol. To recap, this is an unmodified client SDK communicating with our third-party debuggable server. Now, all this information is written up and embedded in a public executable notebook hosted on observablehq.com, and this includes the actual server fake that you can modify yourself. The whole thing is in a single notebook, so you have nothing to install to try this out. And I hope this convinces you that building an alternative Firebase Realtime Database server is not so much work, and actually it's easily within our reach. The obvious next steps would be to actually create a self-hostable server that actually persisted data. And some preliminary steps have been taken. We've developed a Redis driver. I think Redis will match the Firebase Realtime Database as a back-end persistence technology quite well. If you just want to follow along with this journey, then the best channel is probably on Twitter, Tom Larkworthy, all one word. Thank you very much for listening. I look forward to hearing any questions you might have. Thank you.